All right, we are getting into a very, very, very important part of this chapter, of this unit. And this is actually why we made sure that you really understood the two-way tables and the two-way table probabilities, okay? Because we want to look at the two-way tables and we want to ultimately decide if the two variables, if the two things that were in that table are independent of each other. Is one of them affecting the other, or are they independent of each other? And that's a big deal. It actually gets carried out several times throughout this year. So here we go. So again, one of the key concepts is determining if those two categorical variables are related to each other. And so I want us to think about a couple of statements because there are several ways that we can say this, okay? And we've got to get that down, the different ways we can say it. All right, so think about this. If one variable has an impact on another variable, okay, so it has an impact. That means it's affecting it. It's changing it. Do you think that those variables then are independent of each other or not independent? Well, hopefully, if you see that one variable affects the other, they are not independent. Now, we typically want to say they depend on each other, okay? And that's a no-no in statistics. We don't say depends on each other because if we say depends on each other, then that implies a perfect functional relationship where if you tell me an X, then I'll tell you the exact location of its value on the function right here. And I'll tell you the Y value, okay? But we don't have that. Our real data is usually kind of like all over the place. And so it's like a trend. And so we kind of see what's happening, but it's not exactly always depending on it. That would mean it's always on this functional line. Okay, so no depends on. No depends on. That's a statistical no-no. All right. So if we want to say that the variables are independent, so here in this case, one affects the other, then they are not independent of each other. They are related. Something is happening. If the variables do not impact each other, then they are independent. This one is not changing anything about the other one. They are independent. Okay. Again, we do not say dependent in statistics for the reasons that I just explained. No saying dependent. All right. How about this? Let's think about this wording. If one variable has an impact on the other one, so one variable is the fact that you are male or female is affecting the rate, do you think we would say that those variables are related to each other or they are not related to each other? Okay, if the fact that you are male or female is changing the rate at which you eat breakfast in the morning, okay, do you think they are related? And that answer is yes. If one impacts the other, they are related. They are interconnected, okay? They are not independent of each other. They are connected. They are not independent of each other. All right, let's do this word. So we kind of addressed this idea of independent or not. Are they related? And now we're going to say if one variable has an impact on the other. So one is the fact that you are male or female affects the rate at which you eat breakfast. Do you think there is an association between the two variables? Or there is no association? Which one do you think? One affects the other. Then we would say that there is an association. Okay, so these things go together. Hold on a second. So not independent, okay? If they are not independent, right here, not independent, they are affecting each other. They are related. There is an association between them. So let's take a look. They are not related or they are related. Okay. So what do you think is going to be revealed over here on the left-hand side? Not related, and then here on the right-hand side is related. Which one will I reveal is got the word independent? Sorry that those little arrows came in the wrong place. Not related. They are not related to each other. They are not having an impact. They are then independent on the left and not independent on the right. If they are related, they are not independent of each other. Okay, next, what about the next word is association. If they are independent, then there is no association between them. No association. So do you see this is kind of, not related, no association, but yet independent. So we don't have not related, no association, but they are independent of each other. And this is the opposite. Related, associated, they are not independent of each other. So the independent one's kind of the opposite. But if you want to think about which one has the word not in it. Okay, important to keep those phrases straight. Now, let's look at mathematically how we do this. All right, here we go. So, first thing that we have to do is we have to look at the overall rate that something is happening. And so that is called the marginal probability. Marginal probability is coming from the totals. See over here. So this is a problem about gender and what those genders are looking forward to about the Super Bowl. Do they want to watch it for the football game itself? Do they want to watch it for commercials? Or are they not going to watch it? Okay. So overall, we can see what the general public is doing here, the sample is doing. And then we break it down to what are the males doing and what are the females doing. And we ultimately want to see if the fact that you are a male or female is changing the rate at which you do those things. Okay? Now, you might say to yourself, well, duh, there's more males. 720 of them are watching the football game, and only 480 females are watching the football game. So you might say, so males are watching the football game at a higher rate. No, that is not the case, because look, there was 1,800, there was more males in my sample, and I only sampled 1,200, see? So, they could be doing it at the same rate because there were less females in the sample than males. Okay? So let's take a look. Here we go. So watching the game, the marginal comes from the total. So watching the game, that's 1,200 out of the 3,000. So 40% of all subjects watched the game for the game. 31,000 over 3,000 was the watching it for commercials. There's my category. So 33.3%. And then 800 out of 3,000 were not going to watch it. That's 26.7%. So I went over here and I went ahead and I made a stacked bar graph. That is the best way to talk about our independence. And I should have put a relative frequency label here on the side. But these were the totals. So our won't watch, and I think I have a key for these down below, these colors. So see, here was 26.7%. So I came here and I made that won't watch is this bottom 26.7%. Now, I stacked on top of it 33.3. So I didn't just go to 33.3, I added 33.3 to the 26.7, and those two together are 60%. So that one goes up to the 60% mark because watching it for the game was the rest of this bar, which was the rest of the 40%, making it a total of 100% of my subjects represented here. Okay? All right. Now, what we're going to do is go into looking at this conditional upon which gender you are. So it's in green. It's this middle section. It's the part that has to do with you being a male or a female. And so what I want to do then is kind of take a look at them piece by piece. So we're going to take a look at the males first. So the males were out of the total 1,800. So that's going to be my denominator. Given that you're one of the 1,800 males, what rate did you do those things? So my fractions will be 720 over 1,800 for the watching of the game. Okay, Oh, look, I can see. I'll just do it that way. Okay, and then so watching of the game was 720 out of 1,800. And so here's where that looks like right here. There's my 720 out of 1,800. Look, 40%. Well, if you remember correctly, that was the same as the overall rate that were watching the game for the game. So something to keep in mind. Okay, next, commercials. Males are doing the commercials 600 out of 1,800. So I'm going to come down here and I'm going to go, okay. Oh, 600 out of 1,800. That's 33.3% of the males were watching for commercials. Okay. And then, oh, look, 480 out of the 1,800 don't watch the game. So let's see what that equates to. Well, lo and behold, 480 out of 1,800 males is that 26.6. So these males, the fact that you are male does not change the rate at which you are doing the Super Bowl activities. So the fact that you're male not affecting the rate at which you do those activities. Let's look at it for females. For females, my denominator is going to be 1,200. Out of the 1,200 females in my sample, what's the rate at which they watched the football game, did commercials, or watched or didn't watch at all? So let's take a look. So for the females, 480 out of the 1,200 females, see it's a different denominator, and that was 40%. For the females, 400 out of the 1,200, different denominator, that's the female denominator, and lo and behold, this last one is also the same. So, in summary, the fact that you were male or female did not affect the rate at which you watched for the game, watched for the commercials, or you didn't watch the Super Bowl at all. Now, technically, we are supposed to compare, when we want to compare these things, we are technically supposed to compare the conditional to the overall. If there are only two items like males and females, you can compare males to females. But if there's more than just two items, you have to compare to this marginal. You have to. Because one category, like say a third category, that one could have been all waxed up. Two of the three could be messed up, but one of them could be independent. Okay? So we generally compare to the marginal unless there's just two variables or two categories here. Okay, let's graph them. See, here I had created my key for the won't watch, commercials, and games. Well, look at there. They looked the same. So when the rate is not affected, then look, I have males bar, looks like the females bar, and those both look like the marginal or the totals bar. So the fact that you are male or female does not change the rate. Okay? So I want to take a look at that real quick, and then we're going to come back to this response. So over here, this just kind of is an example of where the conditional and the marginal is, and how, now, I manipulated the math, so they were perfectly in sync. But technically, if they are a little off, so sometimes when your fractions are a little off, it's, you can't get completely equal fractions. But they can be within 1 percentage point, and then that can be considered not affecting each other. So we've got this little phrase, this little sing-song, which I will sing to you a lot because it is confusing otherwise. Independent, independent, independent. When the fact that you are one thing does not change the rate. So if the rates do not change, they are not affecting each other, then they are independent. When the fact that you are male or female does not change the rate at which you watch your Super Bowl activity or whatever it is that you are doing. All right, so let's do our full, complete response. There are 3 things you will always write down in your response. Number 1, state if it's related, not related, associated, or the independent, whichever question it asks. Does it appear as though interest and gender are independent? So, what did we see here? The fact that you were male or female does not affect the rate. The rates did not change. So that means they are independent, independent, independent. Now, this second statement is elaborating on this. See, look, I said my gender and Super Bowl activity are independent of each other. And I always start this second sentence because it just makes sense to me to do it this way. The fact that you are, and then you say the conditional things, male or female, and then you say does or does not affect the rate. So the fact that you are male or female does not change the rate at which you watch the Super Bowl for its game, commercials, or you won't watch. So this second statement is an elaboration saying the fact that you are this conditionals ones does or does not change the rate at which you do these other variable things. All right. The third thing is actual statistical evidence. So I then come over here and I say, for example, 40% of males and females watch the game. 33 1/3% of males and females watch the game for commercials. And 26.7% of the males and females won't watch the Super Bowl. So I say what those percentage points were for both of those conditional variables. Okay, conditional categories. So that is determining it independent. This is getting a little lengthy, so I want to kind of give you a little bit of process time. So I'm going to split this notes video into two pieces. So just don't forget that independent, independent, independent. When the fact that you are one thing does not change the rate. And remember that when you are independent, those gender and Super Bowl activity are not related. Nothing was happening. Gender and Super Bowl activity there was no association there. There was nothing happening that your gender was changing things. So we were over here on this left-hand side, not related. Okay, so I'll do the other video and give you an example of one of these other situations and what that looks like. Okay, so let's take a look at that.